Hi everyone! Today we'll be looking at how to find side lengths of similar figures using proportions. So here's today's FLT. Given similar triangles, I will be able to find missing side lengths using the idea of proportions. So in the past few lessons, we looked at the idea of scale factors. Today we're going to be looking at proportions. So proportion says that two ratios are equal. So to say something is proportional means that the ratios are equal to each other. And ratio is honestly just like a fancier way of saying fractions. So here's an example of a proportion. 1/3 equals 2/6. So today we'll be using this idea of proportions to solve for missing side lengths. So how can we use the idea of proportions to find missing side lengths of similar triangles? We actually have two methods to setting up proportions. So the first method is to equate ratios of corresponding sides. What do I mean by this? So let's say triangle ABC is similar to triangle DEF. Let's go ahead and find pairs of corresponding sides. In this case, side AB corresponds to side DE, side BC corresponds to side EF, and side CA corresponds to side FD. We have three pairs of corresponding sides. From here, we can set up a proportion equating ratios of corresponding sides. We would have, for example, side AB over side DE equals side BC over side EF. So on the left side, we have one pair of corresponding sides, and on the right side, we have another pair of corresponding sides. So although this isn't really a formal way of writing this out, hopefully it serves as a good memorization tool. On the left side, we have a corresponding side from triangle 1 over that corresponding side for triangle 2. On the right side, we have another pair of corresponding sides, one from triangle 1 over another from triangle 2. In this method, the pair of corresponding sides are on the same side of the equation. We're setting up ratios based on corresponding sides. We also have another method of setting up a proportion. We can equate ratios of sides within the two figures. One important thing to note here is that regardless of which method you use, you will still end with the same answer. Let's use the same triangles as earlier. So triangle ABC is similar to triangle DEF. And here I've color-coded the corresponding sides. Here's an example of how to set up a proportion based on this method. On the left side, we have side AB over side BC. Notice how these two sides are both from triangle ABC. On the right side, we have the side DE over the side EF. These two sides are sides from the second triangle, triangle DEF. So in this method, on the left side, we set up the sides used in triangle 1. And on the right side, we set up the sides used in triangle 2. Notice how in this method, the corresponding angles are no longer batched together, they're separated. So in this method, we're batching the proportions based on the triangles. So triangle 1 stuff on the left side, triangle 2 stuff on the right side. Like I mentioned earlier, regardless of which method you use, you'll end up with the same answer. So go ahead and try both methods for these upcoming examples and then eventually choose the one you feel more comfortable with. So for our first example, we're given the following. Triangle OPQ is similar to triangle RST. We're going to find the measure of side TR to the nearest tenth. Please remember to draw out the triangles in your notes. So we're going to find the length of side TR, that's this side right here, and notice how its corresponding side is side QO. We're also given another pair of corresponding sides right here. So let's go ahead and set up a proportion using the first method. So for this example, I'm going to try out both methods. So method 1, this one is where we batch by corresponding sides. So on the left side, we have one batch of corresponding sides. On the right side, we have another. So let's set up this proportion. So let's see. Let's start off with side QO over its corresponding side, side TR, equals the other pair of corresponding sides. So side OP over its corresponding side RS. And here's some color coding to hopefully help you out. So we set up this proportion based on equating ratios of corresponding sides. On the left side, we have one batch of corresponding sides. On the right side, we have another batch of corresponding sides. So now let's replace these with the given side lengths. Side QO measures 25.7. Side TR is what we're solving for. Side OP has a length of 17, and side RS has a measure of 59. From here, to solve for x, we're going to cross multiply. By cross multiplying, I get that 25.7 times 59 equals 17 times x. I usually like writing the x on the left side, so anything with variables on the left side. So let me just flip this around and go ahead and plug 25.7 times 59 into your calculator and see what you get. Press play when you're ready. So I got 1,516.3. I want to isolate the x, so what can I do here? I can divide both sides by 17. This will cancel out, and x equals, let's divide by 17, 89.194, and it just keeps going. But we're rounding to the nearest tenth, so x is approximately 89.2. So we set up a proportion to find the measure of side TR. This was using the first method. Now let's go ahead and try out the same example using the second method. So for the second method, we're going to be batching by triangles. So on the left side, we'll have the information for triangle 1, and on the right side, we'll have the information for triangle 2. So I have side QO over side OP. These are the sides in the first triangle. And then side TR over side RS, the sides from the second triangle. So here's some color coding. Notice how the corresponding sides are now across from each other. So side QO and side TR, as well as side OP and side RS. So in this case, in this method, we're batching by triangles. Now let's replace these with the actual given side lengths. So 25.7 over side OP is 17 equals x over 59. We're going to cross multiply, and we get that 17 times x, so 17x equals 25.7 times 59. Notice how this is the same exact thing as we had earlier when we used the first method. So I'm going to fast forward this part, but please let me know if you have questions on any of these steps. So even though the original proportion was different, notice how once we cross-multiplied, we had something very similar to earlier. And we were able to end up with the same answer where x is approximately 89.2. So for this example, I used both methods. Again, when you're working through practice problems on your own, feel free to use whichever method you prefer. For our second example, triangle HIJ is similar to triangle KLM, and we're going to find the measure of side LM to the nearest tenth. So we're focusing on the side LM, and its corresponding side is side IJ. We also have another pair of corresponding sides. So based on this, let's set up a proportion using method 1. So for this example, I'm going to use method 1. The first method is where you equate ratios based on corresponding sides. So one batch of corresponding sides and another batch of corresponding sides. We have side IJ over its corresponding side LM equals side, let's see, how should I write this? IH over its corresponding side LK. So this is probably the most important step to correctly set up your proportion. I have 27.8 over X equals the side length of IH, which is 37, and then over the side length of KL, 7. And to solve for X, we're going to cross multiply. By cross multiplying, I get that 37X equals 27.8 times 7. 37X equals, and then go ahead and plug this into the calculator. I got 194.6. I'm going to isolate X by dividing both sides by 37. And I find that X equals 5.259, and then it keeps going. But since we're just rounding to the nearest tenth, X is approximately 5.3. So in this case, we used the first method, so we batched by proportions to find the missing side length. Let's look at the third example. Go ahead and try this example on your own, and then press play when you're ready. So in this example, triangle MNO is similar to triangle PQR, and we're going to find the measure of side QR to the nearest tenth. First, let's identify the pairs of corresponding sides. So here's one pair of corresponding sides, and here's another pair of corresponding sides. For this example, I decided to use the second method, but it's totally okay if you use the first method. Again, use the method that you're more comfortable with. So the second method is where you batch by triangles. So on the left side, we'll have sides from the first triangle, so side NO over side MO. On the right side, we have the sides from the second triangle, so side QR over side PR. Again, notice how the corresponding sides are across from each other. So let's plug in the given side lengths. 43 over 59 equals, we don't know what side QR measures, but side PR is 14.7. From here, we're going to cross multiply. So 59x equals 43 times 14.7. I find that 59x equals 632.1. And I'm going to divide both sides by 59 to isolate the x. I find that x is, and again, it's like a decimal that keeps going, 10.713, and keeps going. But I round to the nearest tenth, so x is approximately 10.7. So the measure of side QR is 10.7. Well, approximately 10.7. Let's look at two more examples. Notice how this example is a little different compared to the earlier ones. Here, triangle BCD is similar to triangle PQR. We're going to solve for x. In the earlier examples, we were simply finding missing side lengths, but now we're going to solve for x. So let's identify some pairs of corresponding sides. And then based on this, let's go ahead and set up proportions. I'm going to use the first method for this example. Method 1 is where you batch based on corresponding sides. On the left side, we have side CD over its corresponding side, which is side QR, equals the other set of corresponding sides. So side BC over its corresponding side PQ. And we're given some side lengths, so let's fill in that information. 99 over 3x plus 3 equals, the side length of BC is 121. So 121 over the side length of PQ, 44. Same thing, we're still going to cross multiply. I have 121 times the quantity of 3x plus 3 equals 99 times 44. Let's simplify that right side. So I'm just going to keep the left side as the same. And then go ahead and plug in 99 times 44 into the calculator. I got 4,356. What I'm going to do next is divide both sides by 121. So we still have the same idea of eventually isolating x. I'm going to divide both sides by 121, so I just have 3x plus 3 equals 36. Next, let's subtract 3 on both sides. This cancels out. I have 3x equals 33. Divide by 3 on both sides. And I find that x equals 11. For this problem, we're simply solving for x, so we're done here. Here's our last example for today. Triangle ABC is similar to triangle QRS. Solve for x. Notice how we know that the triangles are similar, but they're facing different directions. So let's make sure we correctly identify the pairs of corresponding sides. Side QR corresponds to side AB. So that's going to be this side right here. I also know that side BC corresponds to side RS. Make sure you correctly identify the pairs of corresponding sides. For this example, I'm going to use the second method where we batch by triangles. So side AB over side BC equals the sides from the second triangle, side QR over side RS. And let's rewrite this with the given side lengths. Side AB has a length of 40, side BC has a length of 50, equals x plus 11 over 30. I'm going to cross multiply to help us solve for x. 50 times the quantity x plus 11 equals 40 times 30. That's the same thing as 50 times the quantity of x plus 11 equals 1200. Let's divide both sides by 50 to get rid of that 50 in front of the x plus 11. This crosses out. We have x plus 11 equals 1200 divided by 50, which equals 24. From here, let's subtract 11 on both sides, and we find that x equals 13. We've solved for x by using the idea of proportions. So just as a quick review, you can use the idea of proportions to find missing side lengths of similar triangles. We talked about two methods of using proportions. So there's the method of batching by corresponding sides, and there's also the other method of batching by triangles. Go ahead and use the one that you feel more comfortable with. Awesome job today, and please remember to submit your notes on Canvas. Thank you.